we present EditScribe, non-visual image editing with natural language verification loops. Image editing is a task that heavily relies on visual ability, where one needs to see the image, make adjustments, and visually assess the results, then iterate. However, current image editing tools do not provide accessible methods for blind or low vision people to make adjustments to the image and also lack sufficient feedback for users to assess the edit outputs. To address this, we developed EditScribe, an accessible web interface for screen reader users to make object-level image edits using natural language verification loops, powered by large multimodal models. EditScribe supports 5 object-level edit actions, including removing an object, blurring an object, adjusting the brightness of an object, changing the color of an object, and adding text to the image. Using EditScribe, the user can first comprehend the image content through initial general and object descriptions, then specify edit actions and the target object using open-ended natural language prompts. EditScribe performs the image edit and provides 4 types of verification feedback for the user to assess their edits, including a summary of visual changes, updated general and object descriptions, and AI judgment. Below, we introduce EditScribe through a scenario where Amanda just lost her short-haired British white cat, Elsa, and urgently wants to make a public post asking people to help find it. She uploads a photo to EditScribe and obtains a general description and a list of detailed object descriptions to confirm the image content.
Heading Level 1, Initial Descriptions. Heading Level 2, Initial General Description. 2 cats sitting side by side bathed in warm sunlight, with one cat wearing a red bow tie. A woman is seen in the background, smiling down at them. The setting appears to be a cozy indoor space. Heading Level 2, Initial, Object Descriptions. Object 1, golden-hued wall with light shining on it revealing textures. Object 2, orange tabby cat with light fur sitting and facing forward.
First, Amanda removes Rosa, her other orange tabby cat next to Elsa, to avoid confusion.
Remove the orange cat.
She received verification feedback for the edit, including summary of visual changes.
Heading Level 2, Number 1 Summary of visual changes. In the edited image, the orange cat to the right of the white cat with the red bow tie has been removed. The area where the orange cat was previously is now replaced with a blurred region that blends with the surrounding background and flooring.
AI judgment to provide detailed reasons.
Heading Level 2, Number 1 AI judgment. The edit was successful based on the instruction to remove the orange cat. In the edited image, only the cream-colored cat with the red bow tie remains, sitting on the wooden floor, with the woman still gently smiling in the background. The object description for the orange cat in the input image, labeled as Number 2, is no longer present in the object descriptions for the edited image, indicating its successful removal.
As well as updated general descriptions that indicates only one cat in the image.
Heading Level 2, Number 1 Updated General Description. A cream-colored cat with blue eyes and a red bow tie sits on a wooden floor, looking towards the camera with a focused expression. Behind the cat, a woman, out of focus, leans forward with a gentle smile, as warm sunlight filters into the room, creating a cozy ambience. The setting gives the impression of a peaceful domestic scene.
And the removal of Rosa's description in updated object description.
Object 2, removed.
She further confirms with a question how many cats are in the image, with the answer, 1.
How many cats are there in the image? Heading Level 2, Number 2, Answer, 1.
Amanda then blurs herself to maintain her privacy by prompting,
Blur out the woman in the image.
And also confirms the success of the edit through the consistent feedback from EditScribe, such as,
Heading Level 2, Number 3 Summary of visual. In the edited image, the area where the woman appeared in the input image is blurred, making her features and outline indistinct. Heading Level 2, Number 3 AI Judgment. The edit appears to have been successful. The woman present in the input image, who was already slightly out of focus, is now more thoroughly blurred in the edited image. Heading Level 2, Number 3 Updated General. A light-colored cat wearing a red bow tie with a bell sits on a wooden floor, bathed in warm sunlight, with an out-of-focus person nearby. Heading Level 2, Number 3 Updated Object Description. Object 5, Partial view of a human figure in a blurred state.
To help people better distinguish Elsa, she wants to highlight it and specifies make the cat brighter to increase its focus.
Make the cat brighter to increase its focus.
She checks the verification output after the edit is completed.
Heading Level 2, Number 4 Summary of visual changes. In the edited image, the cat appears more illuminated and exhibits increased brightness compared to the input image. The highlights on the cat's fur, particularly around the face and chest, are more pronounced. The background and the shadows have not significantly changed, and overall image contrast appears similar to the input image. Heading Level 2, Number 4 Updated General Description. Heading Level 2, a cream-colored cat with a grumpy expression, wearing a red bow tie, sits on a wooden floor bathed in warm sunlight. The blurred background suggests a cozy indoor setting. Heading Level 2, Number 4 Updated Object Descriptions. Object 4, brightly illuminated area on the cat.
As general description suggested the cat is cream-colored, but object description did not. She wants to ensure the color of Elsa is still maintained and asks,
What is the color of the cat?
With the answer,
Heading Level 2, Number 5, Answer, cream or white.
which aligns with how her friends describe Elsa before. Next, she changes the bow tie's color from red to blue, which Elsa wore when lost.
Change the color of the bow tie to blue.
She checks the verification output after the edit is completed and confirms the edit by EditScribe's verification feedback, especially that the updated general description indicates the cat wears a blue bow tie.
Heading Level 2, Number 6 Updated General Description. A cream-colored cat with a grumpy expression wears a blue bow tie and sits on a hardwood floor.
Finally, Amanda wants to add her phone number for reference. She first asks EditScribe, dividing the image to 9 squares, where is a good spot to add text that does not overlap the cat, and EditScribe answers.
Center right section.
She then prompts EditScribe, add text, please call 12345 if you find Elsa in the center right of the image. She checks the verification feedback and found the texts were successfully added. However, she is not sure if the text overlaps the cat and asks,
does the text in the image overlap with the cat?
And gets the answer,
no.
Then she want to do a final check if the cat overall looks good in the image and ask,
the cat with blue bow tie stand out in the image?
And gets the answer,
yes.
Finally, she confidently posts it on her social media and waits for responses. To evaluate EditScribe, we conducted an evaluation with 10 blind or low vision people. Specifically, we aim to answer the following questions. How does EditScribe support non-visual image editing? How do BLV people prompt EditScribe? How do BLV people perceive EditScribe's verification feedback? And how do BLV people perceive the final edited images? The study started by a tutorial session. Then, Session 2 to perform each of 5 editing actions. Session 3 to make a flyer to find a missing cat, same as what Amanda did. Session 4 to make a flyer to recruit a craftsman to make a bathroom shelf. And Session 5 to edit the images participants prepared. We found that participants were able to complete most of the tasks in the study sessions and found EditScribe promising in supporting everyday scenarios. On the other hand, participants also expressed a need for more edit actions and finer control over image editing, such as the access to edit granular parts of an object, higher prompt bandwidth to do multiple edits in a prompt, and precise specification of visual changes, such as color code, brightness level. Participants also found it intuitive to use natural language to specify prompts and ask follow-up questions, which reduced their learning efforts. They also developed their own prompt strategies throughout the study. For example, some specified high-level goals instead of direct edit actions, such as I don't want to see the lady or hide the bowl. They also specified detailed prompt to avoid confusion, such as increase the brightness of the cat to make it more visible without changing the color of the cat. For verification feedback, participants found all 4 types useful depending on the context and information they wanted. They developed different strategies and interpretations for consuming verification feedback. One participant commented on AI judgment as internal thinking and reasoning of the system, and general descriptions provided global and comprehensive information, while object descriptions are useful for noting detailed edits and serving as a reference for prompts. Finally, participants were generally willing to use the final edited image depending on the scenario, but expressed the need for further validation from other sources, such as using different AI models or applications or different modalities, such as sonification or tactile display for checking the edit output. Please refer to our papers for more details.